Hi there. Welcome to Physics Mindbogglers, aka PM's first episode of newly launched series, The Researcher's Lens, where we will explore the forefront of scientific inquiry with some of the pioneering minds in the field. And for its first episode, we are blessed to have Dr. Archana Sharma, who serves as Head of Relations with International Organizations and Principal Scientist at renowned CERN Laboratory in Geneva, Switzerland. She was recently recognized by Pravasi Bharatiya Samman, the highest civilian award given to Indians living abroad by Government of India. She was also lauded at British Parliament with prestigious Bharat Gaurav. In this episode, Dr. Sharma shares what inspired her to pursue physics, how she became the first Indian to be part of CERN's team, how can young researchers experience CERN's ecosystem, and opportunities for institutions to collaborate and build credible infrastructure in India that also helps bridge gap between industry and academia. So we hope you enjoy this podcast. Feel free to subscribe PM's newsletter to stay up to date with latest podcast, inspiring stories and mind-boggling opportunities. Hi ma'am, how are you?
I'm very good. Thank you, Pradyan, and thank you for inviting me here.
Thank you. It's a pleasure, and once again, welcome for the first episode of the Researcher's Lens. It's a great pleasure to have you here, and it's one of my dream coming true. Let me give you why I'm saying this because when I was in my high school, I was quite obsessed with particle physics, and it was one of initial topics which fascinated me in field of physics, and one of the factor why I started pursuing physics, yeah, engineering physics for my graduation. So during my high school, me and my friends used to interact about particle physics, and back then, Large Hadron Collider was in use due to its recent discovery of Higgs boson. And we, at that time used to believe there are only three particles, proton, neutron, and electron. So it was surprising and new experience for us to know that there are more than just three particles. And that time we also came across something like standard model of particle physics, and we then explored what this experiment is at Geneva, and we fall in love with the subject, we fall in love with the entire experiment that is happening. So it was a one of my dream to interact with one of the scientists at CERN, and it's really an honor for me to have this opportunity and interact with you. So, ma'am, let us try begin with your journey in this research field. We would like to know how it all began, what inspired you to pursue physics, and then to pursue high energy physics and be part of CERN team.
Thank you so much for the privilege of featuring me in your podcast. Also, in the very first podcast, I would say. So it's quite an honor for me, also. Thank you very much. Indeed, the field is so exhilarating and it's so much, at the edge of knowledge, technology, engineering, that you're fired up all the time. And I'm so glad to see that young people like you are also so interested in the field and so much following what's happening in the world. And really, the Higgs boson or the God particle or the Large Hadron Collider has done a lot in terms of, let's say, bringing the discussion into the drawing room of a middle class family, particularly in India. Of course, I come from
Yes.
India, and I belong to a small town called Jhansi in Uttar Pradesh. Both my parents were teachers. My mother was in the girls' high school, not high school, inter college, it used to be called
Okay.
in those days, and
Mm-hmm.
my father in the boys' inter college, government
Okay.
inter college. So both of them being teachers, life was very regimented,
Right.
very much disciplined, very much on a timetable, whether it's holidays or whether it's school,
Yes.
sessions. So we had literally, let's say, believed that there is some upper force telling the family how we have to operate, which means that, as if there is a rule from the government that you have to get up at 5 o'clock and we have to follow that, So yeah, it was a strict household, which was very normal, I would say, in those days, in the 70s and the 80s when I grew up. And all the family coming from an educational background, it was very much a focus on education, study, and also, I think, in the Indian ethos of academia, getting good marks, and
Correct.
performing well. So I was fortunate that I could get good marks in the schools, and I had very good teachers who somehow inspired me. And I had a very good science teacher in class 7 in my school, St. Francis Convent in Jhansi. The little place had a very good school, and the teacher was encouraging all the time. And I had extremely good interactions with her in the classes. She would ask questions, and you know how me used to be my situation
Yes.
in the class, and she really liked me. That gave me a little bit of impetus to follow sciences in any case. I did not really like biology because, cutting up cockroaches or frogs, which were very common in those days, was just not my cup
Yeah.
of tea. So biology was dropped out anyways. And then came past high school and senior Cambridge that I did. My parents wanted me to study science, of course. And the only choice that remained, apart from getting through medical examinations for doing an MBBS or the IITs, the choice was physics, chemistry, and mathematics. Because
Okay.
I wanted to do something different than everybody else, So
Yes.
physics, chemistry, mathematics really sounded so awesome to me in those days that I said, come on, I'm going to do PCM. That was how it was called. So I went to university, and that move from little town Jhansi to Varanasi, where I was nobody knew me,
Right.
And in Jhansi, it was a community living, it was my life was with the neighbors, with the family, with everybody who knew us. And of course, parents being teachers, the whole town knew everybody, in that sense.
Right.
So finding yourself, finding what you are and what you want to do becomes somewhat a challenge when you are somehow uprooted from a small town. But then that challenge then turns into a passion of proving yourself, that I need to be, head to head, shoulder to shoulder with anybody else out there.
Right.
And I was so fortunate that I got amazing teachers also in my BSc and MSc. So there were women teachers. And while in school, I was dreaming of becoming a school teacher because I loved my teachers, and I said that's what I want to do in my life. When I came to university, I said I want to become a university lecturer. That was my dream at that time, because I loved my teachers, and they become your role models and mentors in life. And eventually, when came the choice of picking up nuclear physics out of all the options that were available, and in those days it was very fashionable to take up electronics,
Yes.
computer sciences, IT. That was very, very fashionable because of the employability
Correct.
immediately after that. And I said, I'm not doing that. I will do something different. And that difference should matter to me, and it should matter eventually to something that I do in life later on. I mean, these are very intricate thoughts which have come to me later on, but they must have, somehow subliminally guided me at that time. So, nuclear physics was my choice, and again, very, very good teachers who taught me nuclear physics. And fortunately, I was then selected as a junior research fellow in Delhi University to start my PhD.
Okay.
And I told my parents that I want to go to Delhi for PhD, and of course, they were very happy with this because was selected there, and I started my PhD. But then PhD does not have a definite end.
Correct.
And these days, with the internet, students grow up with so much of knowledge about how to go about things. I
Right.
was a complete newbie there without much, let's say, ammunition to to move ahead. So
Yeah.
it was really like a maze. You have to find your way on, how to get your publications, how to even do your calculations. And again, the difference of the ethos between Varanasi and Delhi was again another growing step.
Right.
So wherever you feel weak, then you start growing your muscles. And I felt that that was a growth for me, both scientifically and also as an individual, in order to understand what is it that I want to do. So I absolutely loved my work. Even then, I remember how eagerly I would catch the university special bus and go to the Delhi University to do my work. So I had the opportunity of attending a workshop, and in this workshop, I was then offered to come to CERN and to go to a workshop in Italy as well.
Okay. So
And there,
that's where the journey started, and you started working with Sir.
yeah, it was not so simple. You don't get started working with CERN just like that.
In fact, back then you were the first Indian they recruited in their team, right?
So again, this I'm talking to you about 1987.
Oh, okay.
So I told my parents that I want to go there, and my parents said, please, it's time to get married, and that's how, only then will you be able to go there. So I said,
Okay.
fine, let's get married, find somebody quickly, and we'll get married. But I was very fortunate. I got a very supporting family, in law family, my husband and everybody. And that I came here. My husband also came with me for the first time when I came. And I went to that workshop in Italy, which I mentioned to you. It was on instrumentation, in high energy physics, and I won a small prize to come back to CERN for 1 year.
Okay. Okay.
And that actually changed the direction of everything, because when I came here initially, it was only for 6 months in
Okay.
1987.
Ha ha
And
ha.
as I mentioned to you, that for a woman, that is a very important period in life, because I got married. I also had was going to have a baby in 1988, so I had to somewhat be in India, because here there was
Right.
no support system on how,
Right.
for myself. So I went to India, and then after I had a little boy, I became a mother and a PhD at the same time from Delhi
Oh,
University,
wow.
and I came back to Geneva in 1989 again.
Okay.
But again, since you mentioned about the recruitment, what the offer I had was not directly as a recruitee, it was just like being a researcher at CERN.
Okay.
And this was through a grant that was given to CERN.
All
And
right.
that grant lasted for 3 years.
Mm-hmm.
And India was not at all a member of CERN in any way. India
Correct.
was not even an observer member. India was not even an associate member. So there
Right.
was no possibility of recruitment as such.
Right. Right.
So then all this sounds wonderful, but then the struggle began, I would say.
Correct. Correct. Correct.
Yeah,
Correct.
that's how I landed here in the first place.
Nice. But I'm sure that experience must be thrilling, right? From, where you pursued your graduation till you pursued your PhD, and then completely different experience when you started working at CERN, doing the research projects and so on and so forth. I'm sure that the experience must be challenging, but equally thrilling as well, right?
You said it very nicely, Pradman. The thing is that it was very exciting, very exhilarating to be here amongst the best on the planet,
Correct.
in the best experimental laboratory of the planet,
Right.
and yet feeling inadequate.
Correct.
Because in India, I used to come first in class, or,
Correct.
or
Yes.
maximum second or third, maybe sometimes.
Yes.
But here, I came down on the floor.
Mm.
That, oh my goodness, I mean, what technology, what knowledge, what articulate discussions about
Yes.
the subject.
Correct.
And I completely felt like an imposter. The moment I got into the laboratory, I got quite quite foxed at how am I going to manage. But the point is that I had this chance, and I could not let go of this chance to continue and survive and then thrive.
Right.
And Indians are really great at that. When wherever you will see the story where you want to become a donkey and work, the Indians are right ahead on that queue.
Hmm.
So I mean, I enrolled myself for a second PhD. I mean,
Okay.
crazy as it sounds, I did a second
Yeah.
PhD from the University of Geneva
Okay.
because I needed to come to the level of what was required on, and not that I got to fill all my lacuna, but I needed to work very, very hard, and step by step. That PhD took me about 6 years here
Oh,
in
okay.
Geneva as well.
Uh-huh.
But really, believe me, I got the big, lucky strike that
Uh,
I worked in the group of a Nobel laureate, George
yes.
Sharpak. In
Yes.
1992, he got the Nobel Prize. So being in that group without realizing that,
Correct.
you are inside this, surrounded by excellence, you try to just acquire knowledge, and you acquire the passion as well. I mean,
Correct.
of course, I was very passionate, but you don't realize at that time what that
Right.
passion is. You are doing your daily work, and in
Correct.
that daily work, every time you see somebody like him or other people in the group, doing such wonderful work, you want to be like them. So
Right.
they became my mentors and also role models at that time, and I absolutely wanted to be like them. How was an open question at that
Correct.
time. Yeah.
Correct. Correct. But you also were part of this Higgs boson experiment, right? So even that got a Nobel Prize. So how was that entire experience?
So just let me go fast forward, which means
Yes.
what the period from 1987, let's say, up to 2000, the year 2000, I was working on R&D on
Okay.
small little detectors like this
Okay.
size detectors,
Okay. Okay.
where we built the detectors, tested them, did simulations, and worked upon the characteristics of these detectors on how they will respond to radiation. So, in the Large Hadron Collider, the proton beams are circulating, and then they are
Right.
made to collide at the
Correct.
experimental points.
Correct.
And whatever debris comes out of these collisions is what we have to measure. And
Right.
when we measure the, let's say, energy, momentum, and of course the coordinates of all these
Right.
particles that are coming out, if we equal them, it should be the E means energy
Yeah.
in the accelerator should be
Right.
equal to the mc squared, that we
Correct.
are measuring, correct?
Correct.
So my little part in the experiment is about the measurement of muons. And
Okay.
I so when we were doing the R&D in the 90s, I was part of building these detectors which will be used in these large experiments. So in 2001, by 2001, I should say that I had gathered a lot of experience.
Okay.
Without knowing myself, I can tell you that I was just doing everything possible. The bulldozer approach, it
Yes.
sounds a bit crazy, but get up at 5, do the routine, go to work, do everything possible. If you don't understand this, break it down into smaller pieces, solve it. Another challenge, solve it, and make the detector work, make your simulation work, go to a conference, write the paper, do the tutorial, go to every lecture that happens here, seminars, summer schools, everything that you can imagine.
Right.
You would have found me there in those 10, 12 years. I did everything possible in that period, which is what gave me some muscle in my field. I slowly became to be known as a gas detector expert. So when positions were opened at CERN for my kind of expertise, I was just allowed to apply.
Okay.
Normally, you cannot apply.
Okay.
Normally, the if you apply, the application would be thrown in the bin, you know.
Okay.
So with the, and that was the time when you may have seen on my CV that I had started my MBA as well, because I
Oh,
wanted
yes.
to round up everything. I wanted to round
Yes.
up all my skills. I
Uh,
wanted to have something outside of this world that I thought was my whole world, but then there's something else outside as well,
correct.
which
Correct.
was, managing these huge experiments, managing resources, managing people, looking at how you can get funding for experiments,
Right.
and so on. So that spurred me into doing an MBA, which I did only on Saturdays for two
Okay.
years.
Okay.
So my family was, feeding on frozen pizzas and frozen food for for 2 years on every Saturday. But that's how that happened. And while I was doing this MBA, this application to CERN happened also.
Okay. Okay.
So I did not drop my MBA because I would complete it obviously, but then I had to work double time for the preparation of my interview as well. And of course, with my humble experience at that time, it was, I stood out among the candidates, and at CERN, the best candidate would win. And with a lot of deliberations, the Director General appointed me exceptionally in
Wow.
2001.
Wow.
So that's when I came on the LHC experiments, and then came the Higgs discovery, right?
Correct. Correct. But this is quite unconventional, wherein you already completed your PhD degrees, two PhD degrees, and then you also pursued an executive MBA. So, what was the backstory behind pursuing MBA after completing the PhD?
So I tell you, let us be more realistic rather than living in the stars. So I had this fantastic, thrilling, passionate job of working at CERN. And if you were to look at from your lens, as you call it,
Uh-huh.
from India, you would say, "Wow, what a life! Huh? Fantastic!" Correct?
Yeah.
Switzerland, Geneva. Oh my God, CERN, fantastic. But then look now inside through the lens. I had no permanent job.
Yeah.
I was on 1 year plus 1 year plus 1 year contracts
Correct.
from 1989 up to 2001.
Correct.
Family status, I love my country, but I did not get a single job in my country.
Oh, okay.
Okay? I applied. I still remember, going for interviews to various colleges and, other places. I did not get a job. Now
Okay.
comes a time when you are over a certain age where you want to settle down,
Right.
and keep thinking whether to go back to India or go to the United States. But my heart still lies in India, and somehow God has pushed me in the direction where I can do a lot together with students like you, or other people like you. I'm sure you're not a student anymore, but just saying, for me all kids are students.
Yeah, yeah, yeah. Please, I am still a student, I would say.
Me too, me too. So yeah, I mean, which is why I thought, let me also have an MBA, and that will improve my skill set. And believe me, even during COVID, I have done two degrees. Even during
Oh,
COVID.
okay.
So I'm a permanent student. I did a course on high impact leadership in scientific collaborations,
Okay.
and I did another one on sustainable technologies, managing a international project. So these
Okay.
two were from Cambridge. These were the two very big, things that I did during COVID,
Okay.
because there was no commute and so on. So it's not a question of why did I do that, because that has been my training from childhood.
Right.
I mean,
Yes.
if I rewind to my childhood, every summer holidays there were some courses to be done, whether
Okay.
it is stitching or embroidery or Kathak
Okay.
dance or singing or tabla or whatever. Everything that my parents could think of, in their humble, environment. Summer vacations were fully
Wow.
blocked because of these things. So sitting down and doing nothing is a very difficult proposition.
Yes.
In addition, it is also bad because we do not know, we are guilt tripped if we start enjoying ourselves too much. So
Okay.
this is from my generation. My generation has this issue because they are always giving, they are always working,
Correct.
they are always also, it becomes a difficult choice to make, to
Mhm.
just sit down and relax and go for holidays. This doesn't work out. If you talk about holidays, I go to India, I go and meet with the students, or whatever, family, or whatever I
Yes.
can do. So yeah, I hope that answers your question.
Yeah, absolutely. And
Mm.
also very recently, and congratulations once again that you were awarded Pravasi Bharatiya Samman Award, which is highest civilian award for Indians outside India. And you were also awarded by British Parliament Bharat Gaurav. So, was that entire experience?
So again, I'll tell you, Pradyan, that I feel humbled, honored, privileged. However, I must say that I'm standing on the shoulders of a large number of people. Okay. I'm representing an Indian in Europe, in Switzerland. I am representing my collaboration, the compact muon solenoid experiment in India, from CERN.
Right.
And this experiment would not have been possible were there not the thousands of people who built the experiment. I'm one of them.
Yeah.
And then I'm standing on the shoulders of the group of George Sharpak, where I learnt the tricks of the trade, you know, and so on. So, indeed, it is a humbling moment, but good to recognize that our government looks at science and technology as something so important that this award could go to a scientist, because it was the first time this happened.
Yes.
Otherwise, it's usually for businessmen or people
Correct.
making impact in society, in politics. So that was very heartwarming, I must say.
In fact, when I came across your post where you mentioned that you have been awarded, I myself felt so inspired. And when I was discussing that part with few of my friends, uh, they so many of them had that confusion whether to pursue their post graduation, whether to pursue research. But after looking at that post, they also felt motivated. Yes, research mein kuch to hai.
Thank you so much. I'm glad, and once again, I'm happy that even if one student picks this up and comes to research, it's how can I say, my hard work is rewarded. And every time I look at a student who is looking with you know how can I say, ambition and dreams in their eyes to be working, and I think particle physics is amazing,
Yeah.
because particle physics is has replaced the competition by collaboration.
Yes. Yes.
So anybody from anywhere, little place like Jhansi, nobody knows about except Jhansi ki Rani. But they can do it.
Yes.
And in addition, it is challenging. Anything is challenging. If you start doing a diet, it is challenging. So it's this is a career we are talking about.
Correct. Correct.
And I think in India also now there are so many avenues, so many ways to do not only physics but other STEM subjects. There is biotechnology,
Yes.
nanotechnology, and so on. So there are huge opportunities. And now you have the internet, you have the
Yes.
world wide web.
Correct.
So a student in India and a student in the United States or in Europe, in Germany, Italy, France, and so on, has the same opportunity,
Right.
you see, to learn and to grow and to thrive.
Yes. So, I'm curious to know that what are the recent developments and breakthroughs happening in particle physics or high energy physics? Because last big news which we got to know was the Higgs boson, discovery of Higgs boson. So, what's happening right now? What is the current state of experimental particle physics?
So yes, Higgs boson was a big one, and it was a big one of the century, I would say. Already, in 2012 we found it. Very quickly, the Large Hadron Collider started taking data in 2010, and then
Yes.
in 2012, it was already announced. So
Correct.
this was an amazing feat of humanity, I would say. An amazing lesson for everybody on how the vision of the 80s, because the
Yes.
Large Hadron Collider was approved in 1984.
Yes.
So imagine of how this came forward, because even the technologies were not known on how this is going to be built. Correct? So when you're talking of the future challenges, we are at at that moment where we are planning for the future colliders.
Okay.
And these future colliders we do not know how to build.
Okay.
Now, we learn from history. So in the history we have seen that it took 10 years of R&D, another 10 to 12 years of building the Large Hadron Collider, and then now it's being operated for
Correct.
already 10 years, and then another 10 years, and it will operate until 2041. I have already seen the schedule for 2041. Okay, so we need to look and learn about how visionary people are, and
Right.
how we are able to now tackle challenges. So yes, the Higgs boson, just one anecdote I will tell you, that of course we were also excited just like everybody else on the planet who was plugged into the standard model and looking inside the atom.
Yeah.
So I thought, okay, today is the big day. I'm going to CERN at 5 o'clock to watch the historical seminar.
Yeah.
you know the whole room was full, the whole corridor was full, people camped overnight, and
Uh-huh.
I had to really sit in another room and watch the webcast just like you would have done at home. So it's those are the moments that stay with you.
Right.
So Higgs boson has been discovered and is now being studied very carefully. So
Okay.
think of a discovery which nobody knows about, an animal, for example, which looks like an elephant but behaves like a tiger,
Okay.
right?
Okay.
But then when you go inside the guts, there are the guts of the earthworm or something else. So we do not know how this new particle behaves, what are its properties, how does it interact with other particles or by itself. Are there other Higgs bosons,
Yeah.
heavier ones?
Yeah.
And so, do we have supersymmetric particles?
Yes.
Do we have extra dimensions? You know, then dark matter, dark energy, these are
Yes.
all waiting for Nobel Prizes from young
Correct.
people like you, right? So, that's
Yeah.
the horizon that we have in front of us. And of course, I'm very much, let's say, limited in what I do, because these very large experiments need specialists. So we had special engineers who built the magnet of CMS.
Right.
They could imagine how to build it so that we could install, commission, operate, and maintain it.
Correct.
And it's not a little magnet on the top of a table. You
Correct.
know,
Yeah.
it the weight of CMS is 14,500 tons. So it's mind-boggling, just like you.
Boggling. Absolutely. Yeah.
Totally. So my work was in a very niche field, that is in the muon detectors.
Yes.
And similarly, there are people who are working on the physics, who are doing the analysis, who are working on the software, who are mapping every like micrometer of this whole big experiment. Where are the collisions happening and where are we detecting the products? So it's a game in tandem that has to happen.
Right. Right.
So, yes, there are the physicists also who are watching the edge of the physics as well, so that if at all we have a candidate dark matter or any exotic particle, we will not miss it. So, that's what I wanted to say.
Okay, okay, okay. So I just hope that we get some good news that how the future Large Hadron Collider is going to look like, and what more discoveries it is going to bring. So Large Hadron Collider and CERN has been looked at as a European initiative. So what has been India's contribution so far in the field of high energy physics?
So, India is a very rich country for science. We have extreme focus on mathematics and logics, as you know, from times immemorial.
Right.
We have the Ramanujans, and we have the Homi Bhabas and
Right.
the C.V. Ramans and the Bose and so on. So, in fact, if you start from Bose, quantum mechanics and how it has been used in high energy physics really formed the basis of the standard model, right?
Correct. Correct.
And so I would say Satyendranath Bose is one of the biggest
Yes.
contributors to the high energy physics field. And he worked with Einstein, and he worked on the Bose-Einstein statistics, mechanics, and the condensation, right? So that's where his contribution is. Apart from that, we have amazing string theorists in the country who
Okay.
are participating. And I think, because you see, our infrastructure is improving, but not anywhere close to what people have here,
Right.
right?
Right.
But this we have.
Yes.
So we can work on paper, we can work on the computer. We are really far ahead as far as theoretical physics is concerned, and all these new models, proposals. And Rohini Godbole, you might have known, of course, she is
Yeah.
also she's a Padma Shri,
Yes.
and she has been working a lot in theoretical physics, in theoretical particle physics. So a lot of the contributions have been given in theoretical physics, and a lot of the contributions have also been given in experimental, large experiments all over the globe. So
Okay.
not
Okay.
only at CERN but all over the globe. And this started, let's say, with Tata Institute of Fundamental Research.
Okay.
And they, because of course Homi Bhabha was
Yes.
the protagonist over there. So we have a lot of scientists who did cosmic ray experiments at Hyderabad balloon facility. Then of course we had the SS Bhatnagars also working together. So all these things, there was a culture of working with people from abroad already in those times, and those that was forming the basis of the participation in mega science projects eventually.
Okay.
So in the predecessor of the collider, of the Large Hadron Collider, there was the LEP,
Okay.
Large Electron Positron Collider.
Yes. Yes.
So there were participation from India contributing to LEP experiments, like the
Okay.
L3 experiments,
Okay.
from Chandigarh, from Jammu, from
Okay.
Jaipur, from Delhi University, and many others, of course. I mean, I don't want to miss out anybody, so the list is very, very, small. I mean, the list is large, but I can't name everybody. So, participating in these experiments, building apparatus at home, building instruments in India with the industry,
Right.
whatever we could do at
Right.
that time,
Right.
those those instruments are here, and they are in the experiments, and they took data. So they participated in the discovery of the Higgs boson, correct?
Yeah.
So, in that sense, experimental physicists have done their bit, and they are continuously doing their bit by doing R&D in the field, and by uh, producing detectors that can be used in these large experiments. In addition, there's a very big contribution in the accelerator itself,
Okay.
in the Large Hadron Collider. So the
Okay.
Large Hadron Collider is made up of different kinds of magnets, very
Yes.
large superconducting magnets. And you heard that it is a circular collider,
Right.
right?
Right.
So in the circular collider, we have straight sections, and then we have the corrector sections that
Yeah.
correct for the circular
Correct.
nature, right?
Yeah. Yeah.
So those corrector magnets, 800 plus of them, were built in Indore in India,
Okay.
in our industry. Then we have the stabilizers that
Uh-huh.
keep
Uh-huh.
that keep the LHC, very stable. They were also built in India, and there were over 100 engineers from India, from BRC, that participated in the commissioning of the Large Hadron Collider.
Wow.
So all that is a lot of experience that comes
Right.
together. But if you ask my humble opinion, the possibility is hundredfold, because we are such a big country
Right.
and we have so many institutions of world caliber like the IITs or the IISCs or the ICERs and the
Correct.
NICERs, and I do not know. I mean, many are already participating. I mean, I don't
Yes.
mean blanket that this can happen, but the possibility is huge.
Right.
It's huge, because what I see here that industries participate in the R&D as well,
Yes.
and that's where the the leverage of technology happens.
Correct, correct, correct. So, do you think that since India has that kind of capability, that level of engineers, institutions, and resources, uh, like should India or is India planning to build one of these futuristic Large Hadron Colliders?
So I can say that two things on this. One is that it's a very challenging proposition for India because it's a very expensive proposition.
Yes,
It is very, very expensive. And in our country, we do have to look at priorities.
correct, correct.
We need to be there with everyone together. We can't create a big divide of, there's already the digital divide, but of course, India is way ahead compared
Yeah,
to other places on the planet. But then in facilities like CERN, I think we have to leverage what we can from international facilities, and
okay,
we are doing that.
okay,
We have experiments like ITER in France that is looking at thermonuclear energy, which will be like, making a sun, a mini sun, a micro sun,
yes, yes,
where, and India has already invested a lot in the Solar Alliance, as you know.
yes, yes.
India is investing in experiments in United States, large experiments. There's the Dune experiment. There is Fermilab, is a
Yeah,
big, just like the sister of CERN in the United States.
yes, yes, yes.
In Japan, there are other experiments, and then India has its own program as well. Remember that we have the Chandrayaan,
Ah, yes,
we have the Mangalyaan,
yes,
we have the two North Pole and South Pole missions as well.
correct, correct,
So we cannot, just hide behind saying that we can't do this or we can't do that.
correct,
We are
correct,
doing amazing things,
correct,
and I'm so happy to see how fast we are catching up.
correct,
Reason being that we can accelerate this pace because of the democratization of the
correct,
knowledge, and the youth force that we have, youth scientists that we have,
correct,
in fact.
correct,
Yeah.
correct.
So
Awesome.
building a facility in India, in
Uh-huh.
fact, is already happening, albeit at a different scale. We have
Okay.
LIGO India. LIGO
Yes,
India
yes,
is
yes.
there.
Lego India, yeah.
Yeah.
So, has it been built or has it only been approved so far?
Work is going on as far
Okay,
as I know, but
okay.
I know that work is going on, and definitely this is amazing opportunity. I mean,
Correct,
amazing
absolutely.
opportunity.
Especially for the young, scientists, aspiring scientists,
Yeah,
they are quite fascinated
right.
to, work in such institutions, such ecosystems.
Yeah.
And if I'm correct, you also run an internship program in which you invite so many Indian students and scientists at CERN. You showcase, what facilities CERN has, and can you just elaborate on, what that
That's very
internship program is all about?
that's very kind of you to remind me about that. So I tell you what happened.
Haha.
When you leave your house or your home and you go away to a faraway place, you miss your family, right?
Yeah.
And if you see some beautiful scene like the mountains and the snow and a beautiful sunrise, or some wonderful food that you have never eaten before, you want to share it with your family.
Correct.
होता है ना ऐसे?
Yes, absolutely.
So I was really pained with the fact that young students, where I was before, I just got amazing opportunities, and I worked very, very hard so to make use of those opportunities. But then what if I did not get the opportunity? It could have well happened, right?
Right.
And when I look here at CERN, and students are coming from all over Europe and coming here, and the thrill of being at CERN
Yes.
is not the big thrill for them as much as is a big thrill for a student coming from India to see what this place is.
Correct.
And even if they are able to be here, to watch and walk and eat with the scientists here, they will take something back in here. Something will change,
Correct. Correct.
and given their backgrounds today, children come so well prepared that every time a student is working, I mean, just very recently, I spoke to a supervisor of a student, and he said,
Okay.
"Oh, he is brilliant. Oh, he is outstanding. Oh, she is the best student I had." I
Huh.
mean, every Indian student is the best student that we have here. So that is a matter of big pride. Unfortunately, that there are not so many positions or fundings available for Indian
Okay.
students. That is
Okay.
why I started doing something very, in the beginning it was very basic, आ जाओ भाई मेरे साथ मेरे घर में रह जाओ, and you spend a month here. That was how it all
Okay.
started.
Okay.
And of course, because from where do I bring the funding? It's very very expensive to live here
Correct.
in this place. But
Correct.
by and large, slowly, institutions started helping me. So institutions told me that they will fund their students
Okay.
if you provide them the opportunity to work here.
Nice.
And that was my summer program for Indian interns. Okay.
Okay. Okay.
And you will not believe me that it was so successful that many other countries started to do the same.
Oh, okay.
And it happened that now we have an overload of for supervision to find.
Yes.
But i
Yes.
i believe strongly that there is so much to do that every student can contribute, even
Yes.
if it is to build a little part of the detector, or to test some
Correct.
component, or to write
Correct.
a software. So
Correct.
I feel if we work hard, we can find a solution. So that is my little program, by the way. It's just
Okay.
my program. Yeah.
So one thing which you shared with me, few weeks back was, you are also looking forward to uh, uh, develop, India's infrastructure in certain fields, in certain segments,
Yes.
and one of the application which you shared was in the medical field. You know how we can use particle accelerators to treat cancer, and you also shared that such kind of infrastructure already exists in European countries, and they have been there for over a decade. So, can you elaborate on what this idea is all about, and are there any other initiatives or plans which you have to make India more recognized, more well known in field of high energy physics?
Absolutely. I mean, first you learn, and then you gain, and then you try to give back. That is how this works. Whatever little I have learned, I have tried to bring back to my country. And how did I do that? First, you already mentioned about the students, right?
Yes,
But then every student cannot come here,
correct.
correct? So what about doing workshops in the country? Right? So there are workshops happening in institutions, but then there are, I don't know, thousands of universities in India. At least I mean, I don't know exact number, but there must be at least 1,000 universities in India, and we have thousands of graduate students, and we have at least 10% of those wanting to do something of for research, right?
Correct, correct.
In the field, in STEM field, let's call it STEM field, right? Now when a student from Germany or Italy or UK comes to CERN, believe me that from the very first day they become productive.
Okay.
When a student comes from an average university in India, I'm not talking about
Yeah.
A tier and B tier. So that student, despite having a stellar CV, where you have the best grades and the best, I have done internship at Tata, I have done this in the in industry, I have got a patent and I have written a paper. So on paper it is stellar, but when this student is put in the laboratory to work, it takes some time to get started,
Okay.
and the reason is infrastructure. Simple, it's
Yes.
nobody's fault, it's just the way it is. So while I was doing this, all my work, all my research, on the muon detector in CMS, I built from the technology that I was working on R&D in the 90s. I brought that technology into the compact muon solenoid experiment. And at that moment, I would say it was a great opportunity for me to bring this technology into India, into the industry in India, get students interested in it, work in the lab in India with the technology, build detectors, build imaging systems that can be used for hospitals and so on. Because these things have already been done. So we are not
Yes.
going to reinvent anything. We are going to
Correct.
learn and
Right.
then we are going to dream. That's what we
Right.
want to do.
And it also has that application and industrial connect as well. So which is one of
Absolutely.
the factor which nowadays, everyone is talking about, right?
Right. So it just happened again. I was lucky that with the detectors that I worked upon, they can be used in space. They can be used in the airports for security or in cargo management.
Yes,
They
yes.
can be used in medical imaging, as I already mentioned, crystallography, and so on.
Yeah.
So, I went to many universities and many institutions in India. Every time I'm in India, I go to at least three institutions, and which is every other month, more or less.
Yes.
So, I got very interested, and I'm working together with a couple of institutions to build such laboratories in India.
Okay.
That is my dream,
Okay.
to build a laboratory.
Okay.
And it was partially already fulfilled because in the universities and institutions that are contributing to CMS, they already have this laboratory now in India.
Oh,
You
okay.
see, so a replica and more of
Right.
the lab that we have here at CERN exists in Delhi University, for example, or in other places in the country.
Yeah. Yeah.
And so, if a student says, Ma'am, I want to work with you, I say, please go and spend some time in that lab in the country.
Right.
But of course, the dream is to build a bigger central place for
Correct.
all university students who is
Correct.
interested could
Correct.
come and work over there,
Correct.
take data, share data, etc.
And it's just not limited to research projects, is it? it
No,
it goes beyond that as well. So the gap which people are talking about, the industry academia gap, so
right.
such kind of initiatives will help us to bridge that particular gap.
Absolutely. And if we can find the funding, Pradyun, I
Yes.
can start building it tomorrow. But the problem is
Yes,
to
yes.
find the
You already
funding.
have those collaborations.
Exactly.
You also shared that when you were working on CMS detector. So for your part, the muon detector part, you onboarded international collaborators to work on that project and take it ahead, right?
Of course, and many
Yeah,
of them are students, and there
yeah.
are, now I think more than 80 PhDs that have come out from this
Okay,
project.
okay.
And young kids are now team leaders in their institutions, getting prizes from their governments, So I can only be proud, like a proud mom. All are my children there, So, talking about that cancer project, maybe I can mention that yes. So, at CERN, my early stage, as I told you already, was about learning a lot and seeing what's happening. And it was quite challenging. That limit was the time.
Correct.
Just how much can I do even to do my daily work. But as soon as I got a little bit nose above the water, I started looking around what's happening and so on. And I found out, and I learned, of course, as part of the work that I'm doing,
Mm-hmm.
that technologies from particle physics have been applied already and are being applied into
Okay.
cancer therapies.
Okay.
Scientists from CERN,
Mm-hmm.
like me,
Mm-hmm.
have gone back to their countries and
Mm-hmm.
they have built infrastructures and institutions where
Right.
they do research,
Mm-hmm.
where they do treatments,
Mm-hmm.
and they do international collaborations.
Yes.
So these are the three things that we spoke about earlier.
Mm-hmm.
Can we do it in India? You
Yeah.
know? So it is a solved problem. Why
Yes.
do we want to reinvent anything? So,
Correct.
how about making a much smaller infrastructure
Hmm.
but still serving the society,
Hmm.
creating a ground where students can come and play? It's a playground for them,
Mm-hmm.
do their research. Even high school students can participate,
Absolutely. Yeah.
and then of course with the R&D, this center
Hmm.
in 2 years
Hmm.
can generate enough data
Mm-hmm.
that has been taken over the last 10 years in the rest of the world.
Okay.
And why? Think about why. Because
Yeah.
in India we can work. We don't stop at 6 o'clock and say, boss, time ho gaya, ab ghar jana hai. We can work day, we can work night, we can work weekends,
Yes.
and we have the people.
Correct.
In India, there's a population of literally 22 million cancer cases.
Okay.
The population of Switzerland is 8.5 million.
Right.
Okay. So we are speaking about three times the population of Switzerland hanging in there without having recourse to good treatments. In the country, a lot is being done, no doubt. Just mapping this data is a big challenge,
Yeah.
right? So, software scientists are needed, accelerator scientists are needed, clinicians are needed, oncologists are needed, then instrumentation people like me are needed, dosimetry.
Yeah.
Giving the right dose to a patient is a big task. You can't just go and start shooting a
Correct.
patient.
Correct.
So dosimetry, safety, and you name it. There will be 600 industries that will be engaged in this project if I am successful in finding the funding. So I will stop here because I'll just, that's what fires me today. You
Correct.
know,
Correct.
just like I did the prototypes in the 90s, detectors in the 2000 to 2010, and then new technology in CMS from 2010 up to now. My next decade is going to be this one, if there will be those fortunate moments in my life again.
Yes, yes, yes. We just hope that they come soon, and yeah, fingers are crossed. What would be your message to the young aspiring scientists who want to pursue their research in experimental particle physics or high energy physics or instrumentation?
So I think, thank you for the question, because if you were to ask me 30 years ago, the, what would I be doing 30 years later, 10 years later, 5 years later, I wouldn't have an answer,
Yeah, yeah,
because I could not see what I can do.
correct.
And today, I can safely say that children today are at least enabled to see what they want to do. You know. So first thing is that just go big, be crazy, completely crazy, beyond any expectations from your own self. Just we think about your dream scenario, with no money constraint, no time constraint, no world constraint, of the kind that I want to live in India or here or there,
Yeah,
nothing.
yeah,
Today you can go anywhere and still be very much Indian. I
yes,
love my country. I'm living here. I've lived
yes,
more in Switzerland than in India, but still, given a choice, that's where I'm going to go. So, really be bold. And in addition, one has to connect with people, that's very important. You can't be a solo player in an
yeah,
orchestra.
yeah,
And in my field, you have to work together with people. And I think Also there I would say Indians have an advantage because it's our tradition,
Yes.
we have families, we have family traditions, we come together every 15 days for something, whether it's not only Holy Diwali, but we have
Yes.
lots of other little festivals here and there that bring us together. And then I think learning, being a lifelong student is very, very important because things change at a rate which is mind boggling. We do not know how. Today, if you look at the skills needed, were not the same as the skills needed 5 years
Yes.
ago.
Yes.
Today, you need artificial intelligence, you need to have quantum computing and so on. So, you need to be plugged in your field and try to stay at the edge, which means that you be willing to make sacrifices on your time, on your interests, on what makes me comfortable. You have to get out of your comfort zone,
Correct.
right?
Correct. Correct.
And then throw yourself on the job. You will be successful. There is no other way, because if you throw yourself on the problem, there you will find the solution. Absolutely.
Awesome. Thank you. Thank you so much, ma'am, for your valuable time. And thank you so much for sharing your inspiring stories, your experiences. And I'm sure that our viewers must have got, insights on, where the future heads and what they need to do in order to make sure that we achieve those objectives, and India, playing a crucial role at an international level. And we wish you all the best with all your endeavors.
Thank you. The pleasure is all mine, because even if one student decides to take up high energy physics, my job is done. Thank you so much. I really
Thank
enjoyed being here with
thank you,
you.
ma'am.
Thank you. Thank you, Pradman.
So we hope you enjoyed this episode. Do let us know your thoughts in the comments, and feel free to subscribe PM's newsletter to stay up to date with latest episodes, inspiring stories, and mind-boggling opportunities. See you in the next episode of the Researcher's Lens.